Hello everyone, this is Suresh Kumar, working as Assistant Professor Institute of Aeronautical Engineering, Dundigal. So today we will discuss about the very interesting topic like runoff. So here what is meant by, we have to discuss what is meant by runoff and types of the runoff, what is the uses of the runoff, and can be discussed in this videos. Next, the first one is runoff. What is meant by runoff? Runoff is defined as the portion of the precipitation that makes the way towards the portion of the subsurface flow we call it as runoff. So that the flow, and another definition is also there. So after all the losses, the water which is flowing above the ground, losses means infiltration losses, evaporation losses, and evapotranspiration loss, whatever it is, and can be the water which is flowing and above the ground called as this runoff. So next, classification of the runoff according to the source. So in this source, the classification can be bifurcated. The first one is surface runoff. Surface runoff is defined as only the water is flowing, the rain precipitation flowing above the groundwater surface is called as runoff, surface runoff, and it can be flows through the channels, and the streams can be on the stream channels. So it can be next the overland flow. What is meant by overland flow? In this overland flow, what happens? The portion of the runoff that travels over the surface of the ground to reach the streams of the channels, we call it as the in the basin outlet. This process is called overland surface. So next to surface runoff. In the surface runoff, subsurface runoff. In subsurface runoff, the portion of the runoff that travels and reach the streams of the channel underground, we call it as subsurface runoff. Subsurface runoff, it includes interflow and groundwater runoff, we call it as subsurface runoff. So let us see interflow. So the portion of the substance of the runoff that travel laterally in the unsaturated zones of the through the shallow purged surface of the zones, we call it as interflow of the surface of the runoff. The next, groundwater runoff. In the groundwater runoff, we call it as the base flow. In this base flow, the portion of substance runoff that comes in the infiltration and subsequently percolation down to the water table eventually reaches the channel. So such a type of the flow we call it as base flow or groundwater runoff. This process is relatively slow process. Why it is slow? Because the water which is infiltrated into the groundwater and percolated, and the groundwater which is the stagnated in the ground. So this is the slow process, that we call it as groundwater runoff is the slow process. Next one is the hydrological resources of the water can be easily, you can see the diagram, we can easily understand the precipitation which is the evaporation. Of course, we are already discussed about in the previous videos about the hydrological cycle, the infiltration, precipitation, evaporation, and evapotranspiration will be continuous process of the groundwater flow. So we call it as hydrological cycle. Next, here the also runoff will be formed. The precipitation to infiltration to unsaturated soil to the initial flow to the runoff, and also the groundwater recharge which is already enter into the groundwater and store the groundwater discharge to the runoff. So of course the evaporation will be continuous in the process. This is also one of the cyclic process of the runoff. Next, depends upon where the portion of the flow gets continuous, and runoff can be recognized as runoff can be total runoff can be direct runoff and base flow, and surface runoff and subsurface runoff, delayed subsurface and groundwater function. These are all some of the bifurcation depends upon the runoff. It is clear that the total runoff consists of the two types. The first one is direct runoff. The direct runoff is caused an immediate results of the precipitation and direct. Why? Because it can be flowing above the ground level. So that's why we can easily can the results will be the give easy precipitations. Next, base flow is the responsible maintaining the sustainable of the water, can be slowly yearly mainly divides the groundwater, the direct runoff made up of overland flow, surface runoff. Part of infiltration is also which is laterally of the zone soil is going flow promptly. Next, the runoff can be divided. Total runoff can be equal to total rainfall excess plus the losses. Here, the simply we are giving the definition of the total runoff is equal. As we discussed about the runoff means water which is above the ground, as subsurface is also flowing of the water after the infiltration. We call it as surface and subsurface runoff. But here, the total runoff calculation can be the rainfall excess. Rainfall excess is nothing but the runoff plus the losses. So, rainfall excess which also we call it as excess. Here, whenever you have to calculate the rainfall excess or runoff is equal to total rainfall, which is which is collected minus losses. What are the losses? Evaporation losses, infiltration losses, and evapotranspiration losses. These are some of the losses can be also calculated while actual runoff can be known. Next, the effective of the rainfall is equal to rainfall excess plus x, where here x is called as which appears the stream from subsurface runoff. Obviously, the prompt subsurface runoff can be considered and delayed subsurface runoff. Direct runoff is equal to surface runoff and effective rainfall is equal to rainfall excess. So here see that one, types of the runoff. Already we discussed the surface runoff and subsurface runoff already and the base flow. A base flow is delayed of the means the groundwater table streams of the very less movement of the takes place on the airs to reach the streams of the groundwater. Here the discharge calculation is area into velocity. The mean velocity can be flown above the streams to the flowing of the streams. That is the base flow. Next, factors are mentioned. What are the factors? Rainfall patterns. Here see, in the rainfall pattern, how it can be affected in the runoff. In the rainfall pattern, consequence, the runoff is also more. So it may be rainfall just showed that low intensity may not be runoff as rainwater is completely lost in the infiltration and the evaporation. So that is called rainfall pattern. In the rainfall pattern, what you understand that how much the water can be collected from the catchment and which is low intensity flowing of the runoff completely, how much loss due to the infiltration can be calculated. If the duration of the rainfall of the runoff will be also prolonged. That is the next. Next, the second one is the character of the catchment surface. What are the character of the catchment surfaces? In the surface rocks of the surface absorption will actually the runoff will be the more. If the surface impact and clay of the runoff will more. But the surface of the runoff is the main impact. The observation losses will be more to the runoff in the less. So next, factors affecting the very important the climatic factors. How the climatic factors can be affected here in the runoff. So the climatic factor, the first one is type of the precipitation. So precipitation we know very well. All ingredients fog, mist and drizzle and rain, which all mixed we call it as precipitation. We know very well. Already discussed in the previous videos. Next, rain and the snow type. Which type of rain we are? How much the rain? That size of the rainfall can be known here. The rainfall intensity of the snowfall. Next, rainfall intensity. What is the rainfall intensity? Intensity is nothing but the duration of certain period, the rainfall which is we calculated for certain duration. We call it as duration of the rainfall. And duration is increases. What happens? Infiltration capacity decreases. Why? Because the excess of the water is coming continuously, so infiltration will be the decreases as previous one due to increasing the effect of the temperatures. So that is the main reason. Next, rainfall distribution. What is meant by rainfall distribution? The distribution of the rainfall in the catchment will be the, maybe runoff is also varies. How it can varies? The more it is closer to peak of the very quickly of the effect of the rainfall distribution. Next, direct privileging the wind. So how it can be wind? The wind direction is the very important. The wind direction is the towards the flow of the wind. What happens? The peak flow will occur quickly. Why? Because the air will also moves the waves of the rainfall due to the same type of the direction. It will be, peak will be quickly, it can be more due to the air affected. Next, other climatic factors. Other climatic temperature, wind velocity, relative humidity, annual rainfall, or initial losses of precipitation can also affect it. So, how the temperature will, let us see the above one. Next, physiological character. Is there any physiological shape and size of the catchment? So, in the previous slide, what we called as temperature, wind velocity, and relative humidity. So, temperature, what happens? The temperature increases, what happens? The evaporation will be also increases, and the runoff will be also decreases. The wind velocity also increases, what happens? The runoff will also decreases. The relative humidity is same, the annual rainfall. So, next here, physiographical factors. What are the physiographical factors? How it can be affected the runoff is the very important. In the physiographical characters in the watershed of the channel, the shape and size of the catchment. So how the size of the catchment area. So let us see the size of the water. The size of the large watershed, longer time needed to deliver the runoff of the outlet, and small watersheds dominated the overland flow, large watershed by the runoff. How? So let us see the shape of the different type of the catchment areas. Here see that the first one fan shaped catchment area. This is also streams, small streams can be comes here small here, and next becomes the big stream and can be, this is the outlet which is collected here. Next, fan shaped. This is type of the, we call it as fan shaped of the catchment. And third one is broad shaped catchment area. Of course, these are all the streams we know very well. So it can be small streams can be small streams can be diverted into big streams, and again it can becomes into the runoff of the channels. From channels it can be flow through this rivers. So that is the shape of the watershed. So how it can be affected the shape? Here see in this one the shape, the streams which for suppose here is the outlet, we think so. In this outlet what happens, the streams which is comes from this one to this one, the first how it can be affected, that is time to taking for the outlet of the runoff. So here see the also shape that if it is the discharge will be the collected here from the outlet, this is also shapes the streams will be comes from this side to this side. The graphical representation will be shown in the next slides. So this is also the streams will be here. Runoff will be the comes from the quickly will be comes here, and slowly it can be comes here due to the which is comes from the this one to this one. So here the area will be the size will be the size will be the greater. So automatically the it will first comes into the discharge areas. So soil moisture, soil type, and these are also some of the characters will be run out. So soil characters generators, how the soil is, some of this, we have the different type of the soil. It can be mostly affected in the runoff. Why? Because some of the porous, non-porous materials is the porous materials which is also absorbed it quickly and slowly it can be released in the but in the non-porous materials will not be allowed of the slowly it can be allowed, can be removed from this type of the water which is rainfall collected from the top. So these are the type of the soil. Light soil or sandy soils in the large porous, and dry soils are the more water absorbed to the soil, less of the type of the soil. So next graphical topographical characters. So topographical characters means in the best of the things, higher the slope of the faster of the runoff, and the channel characteristics of the length, shape, and also slope of the roughness of the storage density will be channeling influenced such a type of the topographical of the characteristics. Here we also discuss about soil type, soil how the soil moisture can be affected, and soil types, and also topographical characters also affected in the runoff. So a very important drainage density. In the drainage density of the runoff will be calculation is the total channel length total by total area of the watershed. Let us see one of the shape, and previously we discussed here. So see, this one is the total length of the streams. Here, see that one, total length of the streams here. So small streams can be converted into big, and total each and everything you have to get by geographical information system by using the software. You have to calculate all the stream length of each of these streams can be, which is small stream to big streams can be converted by when it comes out from the throughout the outlet of the channel. So here let us see that one total length can be calculated here and divided by total area which is affected in the watershed. That is the drainage density. Drainage density will be very important for calculation of the runoff. Yield is more. Next, measurement of the runoff. Measurement of runoff affected the quantity of the water, that how much is measured by actual measurements, the methods of measured, and subsequently the records of the runoff, and take a daily, monthly, and seasonally, annual basis. But next, here measurement of runoff will be calculated here per daily basis or monthly basis, as and also each of the yearly we have to calculate it. Such data can be collected season wise also we are collected. Such data can be collected and it can be used for designing of the hydraulic structures will forward, and the data analysis which of the area of the catchment can be forward to the those are the designing of the hydraulic structures like dams, culverts, whatever it is, the hydraulic structures will are constructed will be such a type of the data only can be designed for the use of the structures. Next, runoff effects. How the runoff effects can be various things like amount of the rainfall of the vegetation. Too much it can have bad effect of the environment well, and explains include erosion. So how it can be affected runoff. So some of the areas of runoff is increases, the sides of the channels can be erosion of the sides. So this also affected of the runoff. Next, runoff computations. Runoff computations can be these are depends on several factors. So several methods can be also applied: rational method, Crookes method, and curves method, and hydrograph method, and many more. So these are the components. Peaks of the runoff can be calculated. CIA by 360. So here Q is equal to peak discharge meter cube per second. C is the coefficient of the runoff, and I is the intensity of the runoff, and A is the area of the watershed. Like acidic moisture conditions. Whenever you have to calculate the runoff, calculating the designing of the runoff fuel calculation, acidic moisture condition value will be also considered very important for the consideration of the runoff. So acidic moisture conditions as the is considered to be low when there is been little proceedings of the rainfall, high when there is a consideration proceedings of the prior or the modeling of that one. Next, acidic moisture conditions will be the three types: AMC1, AMC2 and AMC3. AMC1, these are the types of the acidic moisture conditions. So first one, let us see the AMC1. This includes the lowest runoff potential because the soils are dry effect of the state study and cultivation to the peak take place. These are the AMC1. So in this one, AMC1 very important. Low runoff will be there. You have to underline, that is the important point. Lowest runoff. In AMC2, what happens? It includes the advantage of the condition of the soil and regarding the runoff generation of the potential. These are the AMC mentioned. Then AMC3 includes the features of the favorable to develop the highest runoff potential of the soil as well as the saturated of the incidence of the rains. The acidic moisture condition is determined on the basis of the 5 days of the calculation. That is the very important of the 5 days acidic moisture conditions. How the affected in the runoff will be known. That is the main 5 days we have calculated of the AMC1. Which one you have to use as a different type of the conditions of the soil, of the acidic moisture conditions of the soil. Next, very important of the SCCS method. SCCN method is the runoff calculation is one of the best method. So SC is not only the best method, it is the accurate method. So when compared to other. So SC Soil Conservation Service and carbon number. CN is nothing but carbon number. So this can be developed by the due to calculation correct value of the carbon number. So what is meant by carbon number? Let us how it can be affected carbon number. Let us see. The carbon numbers will be the 1 to 100. The carbon number actually will be allotted different type of the soil, different type of soils of the conditions, and they will give the sum of the A, B, C, D types of soils can be bifurcated. So in each of the soil they are given the sum of the numbers of each of the research. Directly they are given while we are calculating the runoff calculation estimation on certain particular area of the soil. We can apply how it can be. Let us see in that one. The carbon number will be provided. Also TR55 is also one of the method to calculating runoff. Whereas the TR when compared with TR55, SCCN method is the best method for calculate. Not only that is the accurate method for the calculation of the runoff. Next, runoff will be calculated. Let us see the formula for calculation of the storm. FA by S is equal to Q by P minus IA. So what from the S is equal to calculation here, the ratio retention potential of that one equal to that of the runoff. Here we have to calculate any of the discharge. Here we want to calculate discharge of the runoff. Q is equal, for example, Q is equal to FA into P minus IA divided by S. So like that we have to calculate the discharge of the calculation of the acidic moisture kind of applying the P is equal to PE plus IA plus. This is also one of the formula to calculating of the runoff. Next. So from the Indian soil conditions, what they are given the Indian soil conditions. The acidic moisture condition, the peak discharge will be calculated. Runoff is equal to P. E is equal to P minus 0.3 S whole square divided by 0 P plus 0.7 S. This formula can be generally Indian soil conditions we are using, where the empirical studies of the SCCN method can be estimated. Here S is equal to 25,400 divided by CN minus 254. Here CN is nothing but the carbon number. So that is the by using the general Indian soil conditions can be used of such type of the formulas. So So as I told, in the hydrological soil, the carbon numbers will be how you can bifurcate it. Let us see that one. It can be bifurcated into four type of the group of the soils: A, B, C, and D. Here, group A consists of the runoff potential having the infiltration rates which is wetted thoroughly. They are primarily deep and very well drained sands or gravel will be characterized of this one. This comes under the group A. Comes under the group A soil. Next one is group B. Group B soil consists of the soils which the moderate infiltration of the rates are wetted thoroughly. These type of the moderate of the soil can well drain, and also moderate course of the textures of the soils can be applied for the group B conditions. Next, group C. Group C consists of the slow rate of the infiltration. Here, slow rate of infiltration of the wetted thoroughly, the primarily of the soil layers and the movement of the slow white well, the non-porous material of the soil can be black cotton like that. So these are some of the dust particles will be also inside the layers which will not be allowed the water inside. So such type of the slow infiltration will be developed on such type of the soils. That is called under the group C type of the soils. Next type we have to see the group D type of the soils. In the group D of the soil, what happens? High runoff potential. High runoff potential where it can be happen. Very slow infiltration rate when wetted thoroughly. These are the primarily clay of the soil. Clay soils will be the best examples. High swelling of the potential of the soils at the high water table. These soils are very slow rate of the water transmission. Slow rate of the water. Why? Because having the very low infiltration capacity rates. So that's why this type of the D type of the soils can be comes under the group D. So such type of that the soils can be bifurcated of the A and B and C and D also. There are four type of soils we are bifurcating. So from this one the curve number can be allotted. Let us see the curve number calculation. Here see the curve number calculation. The charge is equal to sigma Cni into Ai by A. Here Cn is equal to curve number for any of the number of n and area of the curve Cn1 and total area of the watershed. Here let us see that one detailed in that one C1 curve number of the calculation. So this is the best example. So after the research, there are different type of the soil. What we discussed in the previously, A, B, C, D. These are the bifurcated of the soils of the conditions, and again it can be bifurcated into different types. So for suppose the paved parked lots and streets and roads, we have to use, if it is A type of this, consider A type of soil, the curve number will be taken as 98 and gravel 76, that 72. If it is B type of the soil, it can be 98. It can be that 82. And again, without conservation treatment is equal to group E is equal to 81 and 82, 91 also and 88 also. Next, poor type of the soil, less than 50% of the groundwater can be grained. The values will be taken as 68, 79, 86, like that. And meadows, grass and grazing of the meadows of the soil 30 and 58, 71 and 78. These are the type of the soil, some of the. But again, let us also there, we'll see. So these are also different type of the soils given. After they given the research, they are giving the data for that one. Easily calculation curve numbers of the different type of the soils. Let us see in the woods and forests we have taken as 30 is equal to A, 78 is equal to B, 65 is equal to C and 73 is equal to D. And next, poor small trees can be brushed we can calculate the current number values. We will take the value of 45, 66, 77 and 83 also. Next it is good grains or brushes covers soil, brush covers of the grass. We will take it as 30, 35, 70, 77 like that. And also fair goat of the 49, 39. So these are the some of the given. This value, what happens this curve? These values, by using this curve, we have to calculate as previously. The curve numbers values can be directly will be take it, and also we can calculating by calculating the runoff. That is the very important by ABCD is the soil bifurcation, as well as soil bifurcation is also from this one. We have to find the curve number easily from the acquired from this table. Next, this is also discharge calculation. Be another in the previously we have to seen in that one the discharge calculation Indian condition. Here see that one general conditions of the soil is equal to P minus IA whole square by P minus IA plus S. So that is the Q is where Q is equal to discharge. P is the precipitation or rainfall. Next one is potential maximum retention of the one. Next IA is equal to initial obstruction. So that is the formulas. Another formula is also evaporation infiltration losses. Other losses can be Q is equal to P minus 0.2 into S whole square by P plus 0.2 into 5S. So these are the acidic moisture conditions. Which formula you have to apply as per your conditions of the soil, as we discussed A, B, C, D, and from the A, B, C, D we have to apply the precipitation. Here P is how much precipitation will be. You have to collect it of different sources, and S value is also given P plus 0.5S, and curve number will be 25 by 45, 25 into S. This is the CN value. S value is equal to potential 1000 by curve number minus 10. So N value ranges of generally the all you have to observe from this previous table. The curve number will be the 0 to 100 only. Within the 100 only the curve number will be taken. So here direct runoff Q is equal to direct runoff, P is equal to rainfall depth, S is equal to retention capacity, and Cn is equal to curve number. Depends upon different type of the pattern of the soils. So this is all the process of the calculating of the runoff of the different type of the conditions. So this is the briefly about the SESCN method. We have to discuss curve number, how to calculate runoff, and type of the group of the soils will be discussed in this lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.